So the show have actually started, not really, not the show, but the event itself. So people are gathering. Okay, I just realized that the 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, I just realized that the sound is doubling because I was enabling both microphones. One, two, three. But actually, I think it's Mr. Johan.
Am I live? Sorry.
No one is hearing you because I can't figure out which.
I don't know. So that's fine.
Hey, it's totally fine. Come on in.
Sorry? Picture now. There we are.
Live streaming right now.
Live and direct. You want to say something?
You can say hello, wave to the camera.
I will give you this thingy so you can talk in it.
But also,
And also that one.
yeah, exactly.
So John,
Yes.
when I leave it up to you.
Yep.
I will give you this thingy, mount it on you. Then you will give it back to me.
Okay.
And then I will give it to Anna.
Ah, okay.
This needs to be.
To be able to the live thing. Okay, okay. So we have, and this is for the sound here.
Yeah.
And then we mount that on Anna. Or she has on her own. Okay.
She needs this as well.
Okay, cool.
Everyone should have this.
I see. And I'm wondering if I can just, like, to make it easier. Take it.
Yeah.
Because it's so short. Yeah, it's short. Can be also fun.
Yeah.
Needs to be close.
Is my microphone working?
This one
Are we having?
doesn't look like it.
Are the projectors?
Oh.
Hello.
Oh, it
Can you walk to that corner and say hello like you did, but there. Two things got broken.
No.
The sound, I have no idea. Look. Okay.
Streaming coming on.
Yeah.
It's working?
Yeah, you can say hello, wave to the camera.
But is the sound working now?
I'm trying to figure out what sounds are we getting up because it's definitely might be me or it might be the notebook.
Wait, can we send the link?
Don't do it. Yeah, if you want to be ashamed, of course, sync quality. Don't do it. Copy and I will send it to you. Oh, another thing that we didn't work is remote. switch the screens because one screen is the camera itself. So as you can see,
How did you manage to get it to work?
this is one thing. Yeah, there is another setup for the slides and we can camera. I probably will also turn on the recording because it's fine. I think you know. Yeah, I did.
And do you get the projectors to work? Because now they're not on at all.
Yeah, no. I think we're just hiding them from the audience.
Because I think it can be good to just like have something that we know that.
We should have.
Maxim, dude. It's not working for a shit.
Hello.
Cool.
It's not working at all.
Oh, now
How do you
it's
know?
almost on.
Because I listened in my phone. Couldn't hear nothing.
Not like on the
So can you help me? Then let's figure this out together.
Hello, mixer man.
Look, my man.
So this
Look,
might be
my
turned on.
man. There is a bunch of microphones.
Bugs in your software.
It's shit. It's shit, man. I wasn't able to
Hello?
turn on the remote control.
Well, that sucks.
So there is a bunch of audio inputs. I have audio input capture,
But there's no
and there is 3 options: default, microphone, default
is-
audio interface. So it's either default,
Yes. Does this work?
default.
Hello. Can you hear me? Hello.
Hello. Can you run away, yell something, and then get back
Into the microphone?
into the microphone, as
I will do
always?
that for you.
Say something.
You want some more minutes?
No, it's fine. Look, man.
Working, dude?
This shit is not working. Sound is being picked up by the notebook. It's
Goddamn,
good.
you notebook.
No, goddamn this microphone.
Ja, usual. Jag får rätta den.
Whatever.
You have maybe that's too late to do now, but do you have like a backdrop with where it says your meetup name or?
That I wanted to say to you a few minutes ago. But
Yeah.
no, I don't. Something to always have. If we have a meetup, have a slide for this.
Oh yes.
Yeah, that's good. Live direct.
And the sound works? No.
It's picking up the sound.
It's being picked up from the.
So you will have to stand really close
Ah,
here.
so the mic is actually. Ah, okay. with the back towards the hard body. We had two more guests. Yes, and they're up now here. So just got in.
Dude, you tried to do the live. I will start.
Yeah, I'll just.
You want to be on stage?
I will be on stage switching camera back and forth. You gonna be here? Sort of. But I will be quiet as a little mouse. Good.
You need the green light, yeah. Cool. I'll put on the sound.
Hello guys! Hello! You hear me? That's good. I'll start over here. We got a live stream. It's live and direct. Believe it or not. I'm Mikael, and you're the audience. Welcome to this Stockholm React.js meetup. Woo! So we have two great talks for you tonight, and maybe some surprise lightning talks if you're up to it. If you are, contact me. I'm here, so you will recognize me by my face somewhere in the audience here. We're at Netlight today, and they would like to say a couple of words before we begin the evening. So here's John. A hand for John.
Hello, and as Mikael has told you, you're here at Netlight. Oh. So this is the live streaming mic?
Yes.
Okay, double mic. Yes, and for you who don't know what we are doing, we're an IT consultant company working with, in Stockholm we have 130 different clients, and React is something that we work a lot with, and we share a lot of knowledge within our company, and this is also why we think it's so great to, with the Maxim and Mikael here, to do this with you. So yeah, and my name is John, working at Talent Search here at Netlight. And some practical information. One of the most important things is if you're gonna leave, hopefully not right now, but when you're gonna leave, then if you use the handle, then the alarm will go. So, and if you press the red button, which is not that logical, but if you press the red button, then the door opens and then it's fine. So, but that's a good thing to remember. And otherwise we have toilets down there, and you can also put your trash in the garbage can over there. So, yeah, back to you.
Thank you, John. A hand for John. Awesome. So we had some food, we had some drinks. If you didn't, probably hungry or thirsty. So if you didn't take a burrito, there's burritos behind you. Same with food or drinks. Awesome. So without further ado, let's introduce the first speaker of the night. It's Anna. She will talk about scaling game UIs. An applause for Anna.
Hello? Follow me. Okay, so, can you hear me? Okay, nice. Okay, so I'm gonna double microphone now.
Put it where you want.
I don't have that much space left, so I might hold it.
If it's fine.
Okay, mic me up.
There you go.
So, thank you. Okay, so, I'm Anna. And as Michael said, I'm going to talk about scaling a UI in a multiple platform game. So, first, some stuff about me. I'm a web developer, but I have a background as a UX designer. When I'm not working or talking, I enjoy painting, playing video games, and listening to true crime podcasts, and usually a combination of two of those. And which ones do you have to guess? So I currently work at a game company where I use web technology to produce UI. And I sadly can't tell you which game company because of reasons. What I can say is that they produce a game that's very, very popular and it can be played on almost any platform that you can think of. So Android, iPhone, Mac, PC, Xbox, PlayStation, Switch, etc. Also Kindle, if you're into that. So what's happening right now, and the reason why I am at this company is because we're updating the UI. So we're updating both the design and the technology for the UI. And we're doing this using web technology. So we're building it in React, but we're rendering it with a third-party custom rendering tool that contains a subset of the web technology that a regular browser has. So the idea behind this is we're going to create a design system with reusable components built in React that can be rendered on all the different devices that this game is going to be played on. And since we are building it ourselves, and we're not rendering this in a regular browser, we need to handle basically everything by ourselves. So what I'm going to talk about is how are we going to make this UI scale. So we're not going to do what most people are used to when it comes to web. We're not going to have breakpoints where we change the design depending on the device. So we're not going to have like a mobile design. We're not going to have a desktop design. We're actually just going to scale the UI. So we need to find a way to do this. And the first thing we did, the first thing we started to do, was we decided we're going to use REMs and VH. So I think most here have tried REMs or are using it right now. But just to quickly iterate what it is, it's a value that's relative to the root M, so it's relative to the base font size of the document. So if the base font size is 16 pixels, that means that one rem will render as 16 pixels, and if the base font size is 10 pixels, one rem will render as 10 pixels. So that's what you need to keep in mind when I'm talking about this. And when you set the base font size in VH, that means that the base font size is going to increase and decrease depending on the size of the window that the UI renders in. So we're actually going to use this. So just again to iterate, if the base font size is 10 pixels, which we decided to go for, we don't want to use the default 16 pixels because it makes life more difficult to have to divide by 16. And we're god over this solution, so we're going to go with 10. So that means that when we put in one rem, it's going to render as 10 pixels. And if we put in one VH as the base font size, that means that if the window is 1,000 pixels high, one rem is going to render as 10 pixels, because 1% of 1,000 is 10. So, for this to actually work, we need to translate the design that the designers give us, that are given to us in pixels. We need to translate them into rems. So what we're going to do is we're going to divide the pixel values by the base font size, which is 10, which means that 20 becomes 2 pixels, 40 becomes, 4 rems, and 16 pixels becomes 1.6 rems. So, this seems fairly straightforward. Like this is going to work out nicely, we think. Because on a smaller device, the window is going to be smaller, the UI is going to be smaller. On a bigger device, the window is going to be bigger. It seems like it's going to work out nicely for us. However, we quickly realized that this was not going to work because in the UI, we noticed there was a lot of glitching. There was a lot of uneven spaces between borders and divs. Margins didn't align as they should, and things generally didn't snap. And this is something that you really want in a game. It's not acceptable to have a very unpredictable, glitchy game UI. And here is me just showing that if you look between the divs here, you can see that the spaces are not behaving very nicely between the green divs as I change the height of the window. And it's easier to see if you look at a print screen. Oh, sorry. So, in the CSS, these two margins have been given the same value, but they still render differently. And to the right, you can see it looks super ugly. And when this keeps occurring, it looks very buggy and just generally not nice. And it was especially visible when it came to thin borders and margins. So, as some of you might have guessed, this is caused by subpixels. So, this dynamic scaling that we created, it's going to create subpixels because a window can take any height it wants to, meaning that we will have this glitching issue. And apart from that, we're also going to have an issue with not being able to predict how the UI is going to behave, since it's going to be different on all devices, since it scales linearly. And as my tech lead said, he fucking hated the VH thing, because it created so much headache for us. So we had a lot of issues with coming up with a good way to work with design, because design didn't really know what to use as a base. And when we implemented what design gave us, we didn't really know if we had succeeded, or if we kind of succeeded. And we also had an issue between us in the dev team, because we couldn't really compare what we implemented between us, since we had different resolutions on our screen, etc. And another major headache was the typography, which was also, this was a nightmare. So we're going to have to come up with a way to get rid of the glitching while still having a control over scaling. So we realized that, okay, we need to find a way to both design and scale so that we're going to keep to the pixel grid. We don't want the subpixels, we want the nice, like, snappy design that you see to the right here. This is like a goal image. So we have to let go of the linear VH scaling. It's too unpredictable, it's too hard to control. We want to instead move to something that's snapping and in steps. So how can we do this? We have to let go of the VH, as I mentioned, but we still also need the REMs to render as even pixels, and the scaling to result in even pixels. And as I said, we need to do it in controlled steps. So we still want to use the base font size because it's so powerful. It's very neat to be able to control everything in one place. So what we're going to do is we're going to continue to use the base font size 10 pixels. Then we're going to increase and decrease the size of the scaling with 25%. And 25% of 10 pixels is 2.5 pixels, meaning that we're going to increase and decrease the size of the base font size with 2.5 pixels. And this is just a visualization of this. So you can see on 0, when we have 0 steps in either direction, we're on 10 as the base font size. If we step one step, we reach 12.5 as the base font size. And for that other way around, you can go down to 7.5, to 5, 2.5. So this is a way that we can actually control the base font size in a very mathematical, easy to predict manner. So since we've lost the control of the VH, the very neat, almost automatic scaling, we need to connect this math that we decided to go for with the actual height of the window. And to do this, we're going to actually have to care about the resolution of the screen, of course, and we're going to treat it differently depending if it's DPI aware or not DPI aware. So, for a handle device, we're going to use the first generation iPhone as the baseline. So the amount of, when you take your device, for example, an iPhone X that I've used here as an example, it renders 3 times more pixels, approximately, than the first generation of the iPhone. So we're just going to increase the size of the UI with 3 times, which becomes 8 steps in this graph I showed you. For a desktop, we can say they've changed the window size to 720. That means it's half as big as 1080, which is the base size that our designers designed for. And for a TV that's 4K, that's actually twice as big as the design that designers designed for us. And all of this means that you can see we have calculated, okay, it's half as big, it's twice as big, but how is this related to the steps? So it's easiest to just show in this graph. We're starting on 10 pixels, but we want to double the base font size, so we double the size of the UI to be able to look nice on the 4K TV, which means that we need to go 4 steps to reach this 20 pixel base font size. For the desktop that's just 720, we start on the 10 pixel, but we want to half the base font size, meaning that we need to go back 2 steps. So this is what I'm talking about when I talk about steps. Okay, so now I have the scaling, super nice. However, we of course need design to work with us when we do this, because if they don't follow this 25% scaling, the UI is still going to look super poopy. So we needed to find a system that made that, okay, 25 up and down, what works well with that? Okay, we know that 4 actually works really nicely with 25%. So you can see here on the right some very advanced math that shows that when you increase and decrease 25%, it results in nice even pixels. So we need the design to actually use this base 4 grid for the pixels when they do their designs. So what this means is, if you have 0 steps, the base for the design, not the base font size, but the base for the design is going to be 4 pixels. If you step up one, it's going to be 5, step down, it's going to be 3. So, what we need to do when we implement our design is that we're going to put it in rems, but we need the rems to be evenly divided by 4. And since our base font size is 10 pixels, when we haven't scaled up or down, that means that 0.8 rems is going to render as 8 pixels. Super nice. However, there's something weird with this slide because there's a border here that's 1 pixel. That doesn't really fit into like what I just said. I just said we need to have a 4 base grid. So what we actually need to do, we can't allow everything in the design to start on 4 and scale as quickly as the 4 is going to do. The designers wouldn't allow that. Or they shouldn't allow that. So what we need to do is we need to have a custom scaling that's going to allow for 1 pixel and 2 pixel scaling, meaning that it starts on 1 pixel or starts on 2 pixels and then scales up slower than the rest of the UI. So what we did is that we created 2 different scales for these 2, and then we used them as variables. So in the CSS I showed previously, what we do is that we actually, in this border, we call this variable, that's the base 1 scale. So here we can't decide how many rems we want to use. We just say, okay, we want it to start with 1 pixel, and then we let the math do the increasing of this border. So what this actually means, just to like combine what I've been talking about, if we start on this 0.8 rem height and width div, when we go 1 step up, the base font size is going to be 12.5 pixels, meaning that this div is going to render as a 10 times 10 pixel div, but the border, it follows a different type of math, a different scale, so that's not going to increase. And to illustrate this a bit clearer, so here's a graph, and in blue here you can see it's the base 4, so everything in the UI that's based on 4 pixels is going to scale up nicely, like 1 pixel per step in the UI, while in red, the 2 pixel scaling starts on 2, doesn't increase in size until you have step 2 steps. And the 1 pixel in yellow starts on 1 and doesn't increase in size until you step 4 steps. So this is how like it's all related. So what this has meant to enforce it, there's been a lot of talk with design, of course, because we need design to like work with us. But we also added a custom linking rule to make sure that everything we put into the UI is actually evenly divided by 4. Yes. So. Okay, so what are the takeaways about what I've been talking about? So we need the base font size to render the rems in nice even pixels because we want to use the base font size for scaling. We need the scaling to happen in controlled steps, and we're going to use increase and decrease of 2.5 pixels in the base font size for this to happen. Design needs to follow a 4 pixel grid, so that the 25% increase and decrease will make sense. And the borders and other parts of the UI that can't follow the scaling will need to use their own custom scaling. And yeah, exactly as I said, by tightly collaborating with design and by using our custom linking rule, we can actually enforce this and make sure that this is what's going to happen in the UI. And all of this has meant that we have gotten a lot more control of the UI. We can actually predict how it's going to look. It snaps nicely, we don't have the ugly glitching. So yeah, our lives have gotten a lot better using this scaling. So in the future, we're still pretty early in this implementation. So it's inevitable we're going to find like new issues to solve, but this 4 grid scale grid, or 4 pixel grid, anyways, it means constraints for design. We don't really know how it's going to work out moving forward. Like as of now, it's been fine, but we like decrease the amount of freedom they have quite a lot using this. And we also have an issue with assets and images that are not evenly divided by 4 because they don't render nicely in this grid. So either we need to redo a lot of assets, or we need to find another solution for these pixel assets that we use. So that was it. bad. I wish I had a really good answer for that. What I would say is, we found out afterwards that 4 is actually like a branch standard, just because it scales really nicely. Like you can use 25% really nicely with it. My really boring and not very detailed answer is that it was a combination of like design. It was like the chicken and egg situation. Like we tried some stuff out, and then we realized that 4 is going to work nicely with that. It's a very valid question. I wish I had a better answer for it, but I don't. Yeah, I would say, yeah.
I was wondering if that system going to work nicely with movements and animations?
That's also a really good question. From the implementation, actually I was working today with animations using this, and it looked nice. I don't know, I haven't reached any limitations so far from what I know. Do you have anything like particular in mind when you...
No, I'm just thinking that it will work nicely.
You think because it's gonna like be sub-pixels as it goes?
Yeah, maybe.
Yeah, I'm not sure. So far I haven't noticed anything. But as I said, it's early days, so we'll see. But it's a good question. Yeah. Anyone else? Thank you.
Awesome. Thank you, Anna.
Thank you.
So before the second talk, we will have about a 15-minute break. So we can mingle around, have more beers, have some food, go to the toilet, etc. So we'll be back in 15 minutes.
Grazie.
Prata på någonting.
Kör på lite.
You did good. Really good.
Thank you.
Awesome.
I didn't nervous down. I wish people would have asked more questions. Because of my graphs. My lovely graphs.
Yeah, they were, I mean, people, those were like harder when you going to like explain like how you thought, not like,
Sometimes maybe I should have talked longer.
Well, it's hard to tell because I have no idea. I think it was just fine. But you shouldn't be.
Good. I just wanted to make sure I didn't like talk like 10 seconds.
No. It was decent length.
Thank you. Okay, then I'm gonna... Okay, so what can I not remove?
I guess you
Oh yeah,
can.
if you want to have a lightning talk, just talk.
Totally can compose.
So what can I remove now without like causing havoc?
Just remove the thing that goes into your... No! Yes, it's fine. Just remove everything. It will be another laptop. I will set it up once.
So,
Yeah. Because that's not connected to the live stream.
Yeah. It actually is very enlightening experience. I have no idea. There's so many problems. Whoa. I'm surprised.
So nice.
Yeah.
You always stand?
I think it's an actual start. Where are they now? Where they going?
Then we have like
Netlight. Oh wait. Like colored.
yeah.
Camera. It's very unstable.
I see if I can go find the LED lights actually.
It would be awesome.
Yeah.
So let's set it up. Okay. What goes where? This goes in. This goes in. Yeah, just send just insert this into your notebook.
Come in.
Yeah, just connect this one. Can you start the presentation and open the first slide?
Or do you need me to?
First slide.
Do you need me to have the screen mirroring?
I think, however you like, anyhow you would use this projector, use this one. It will just propagate the picture to that one.
Yeah. Alright. Do you mind if I try just setting it? Because it would be helpful if you see the next slide.
Let's try it. We have time.
Do we have any viewers on the live?
You know, actually, yeah, we had like 3 people. Now it's 5.
Wow.
They would say hello and
Wow.
stuff.
There will be millions.
Soon. Yeah. It's surprisingly complex. But dude, it works.
Yeah, that's very fun.
Yeah, it works. Okay.
Just like that. Wow. Sam was complaining about the exact thing you're going to talk about today. Aha, really?
Migrating from
Literally
Gatsby.
like 2 hours ago.
Where did you move? What is it now?
No, we're still in Gatsby, but he's talking about killing Gatsby. I just had a conversation about this exact thing 2 hours ago.
He might be
Okay.
biased.
Yes. Pretty sure. But I have a solution.
Come in.
I have a solution.
Oh, interesting. Yeah, Gatsby has released hosted previews.
Hosted previews.
Instant previews
Nice.
with webhooks. So we can actually ping from our backend and immediately updates. No wait.
That's so interesting.
Yeah.
You could have a talk about it. Lightning talk.
I worked out today stupidly because I still have a cold. It destroyed my lungs and I have like a really sore throat now. So I
Okay.
don't want to speak. I don't want to say it.
Okay, but it would be a nice lightning talk.
Yeah.
Look, my dudes, for this talk we have a solution. Here you go.
We're very solutions oriented here. At
Yeah,
HJ.
exactly.
Do you mind if I put in my character list? That would be like a sucky thing to fail on. Also, this clicker thing, did it work out of the box? No?
Yeah, it does. Like you do your presentation, your computer, it just propagates it to the stream and then to the projector.
Oh yeah. But I mean, can I plug this in and it will work?
I think it should work fine.
I'll try.
Take that for the top.
That's it.
That was for me. That's out.
Oh, fuck.
so far we have a break. How do you do it? Would it let people write something? Tell us something. Let's talk a little bit. Maybe. And soon we will get back to
Se på den här panelen. Så man väljer egentligen, det är bara man väljer source. Så det är svårt för om man typ så här sänker här, så sänks det allting, inte i mackan av dem. Så att man får trycka på det om det är så billigt.
Okej. It is.
Nice.
Hello. So, yeah, in 5 minutes we'll be back. So, 5 minutes. There you go. Hello, people. Can you hear? Is this on? It's working. I think it's working. Hello. Welcome, live streamers. We're live. Usually. And I hope you had a good break. I did. So we have another talk about Gatsby. Actually, about what you use Gatsby. It's by Johan. Is Johan here somewhere? Can we get Johan up onto the stage? Okay, big applause. You have a... No, I don't need that. You will get a microphone.
Thank you.
Easier to talk.
There you go. Hey, fancy headset. So just go around. Pick up sound.
Is that my sound or not really?
I will check. Talk.
I will talk. And
I think you're good.
I'm good. Okay, good.
You wanna have
2 mics. Cool. And a clicker. I'm set. Who here is using Gatsby? Lots of hands up. Who is using Gatsby in production? Few hands up. And who is thinking about using Gatsby in production? Some hands. Cool. And this talk is, of course, not about Gatsby. And to start with, I just wanted to share this image, because I think it's somewhat relatable. When you start a new front-end project, you have all these build chains and tools and dependencies you want to pull in just to make a hello world. And I think Gatsby has kind of come to fill a void where simplicity is key, because Gatsby is a static site generator. So it's just kind of builds static files, it makes HTML files for you, which makes them your pages kind of server-side rendered, and your assets are bundled with it, and it's very easy to host. And so I think it kind of fills a void and goes back kind of to the 90s, where you made websites and you hosted them on a web hotel, and Java was still considered groundbreaking, and I looked like this. And who am I, anyways? I'm Johan. I nicknamed Pullman HQ. You can find me wherever you want if you want. And I've coded since I was around 10 or 12 or so. And I work for a company called Hedvig. And who's Hedvig? Hedvig, we sell not kind of double clicks my slides. Anyways, so we sell nice insurance. And what is nice insurance? Nice insurance is when or traditionally, an insurance company kind of takes your monthly premium, puts it in a big pile of money, and they pay out the claims they have to from this pile, and the rest they take for profit, which from what I've heard is around 40%. It's quite a lot. And so what we have Hedvig do instead is we still take your monthly premium, then we take a fixed cut of 20%, pay out the claims that we have to from the rest of the money, and whatever is left at the end of the year, we give to charity. So we have no real bias of not paying out your claim. We also keep source code public, and we keep open source very close at heart. So if you want to, you can find us on GitHub, and you can see how an insurance system looks like. And we're quite an app-focused company, but we do have some web components, among them being our web onboarding and our public website, hedvig.com, that I will be talking about. About a year ago, hedvig.com looked something like this. It was built on Gatsby by quite a few consultants, actually. So it turned out a little messy, no offense, Netlight, regarding consultants. But you know, when you put a lot of different people together, and then things can get messy sometimes. But still, it was a very decent setup. We were using Gatsby, and we hosted it on Netlify. Netlify is really a static site generation hosting provider, and it's kind of on steroids. It gives you a built-in build process. It allows you to handle different environments. It also comes with a very lightweight CMS, which lets you check in all your content into Markdown files. And so your content is actually just Markdown files. And so every content change would open up a pull request in our web repository. And when we want to go live, we merge the pull request, and boop, it's built out in production. It took around 10 minutes or 5 minutes or so, I think. And the CMS looked something like the above. So the content editors would have some fields on the left and a preview on the right. It wasn't really how the site looked, but it was to give them a hint of like, this is what it's going to look like. So this is quite a kick-ass tech stack. Or because we have this person at our company we call her the content queen. And she wrote to me, and she said, hey, Palman, because I got the name Palman because we have two Johans. I just wanted to check if there's any chance we can make a landing page that looks exactly like the start page, except we remove the third section and put some other copy in. And this is not an undecent request. So what I did was I just kind of made a little switch for the third section and put different copy in a different markup file. And then she came again, and she said, actually, could we just switch section 4 and 5? And of course, only for the new landing page. And that's a bit trickier with the CMS, but it's fairly easy. You kind of make a different page template, you reuse your components, and boom, you're good. But then she came again, and she was quite upset because, you know, is there no way of getting the build to run any faster? It drives me crazy that I have to wait for over 5 minutes every time I make a change to see how it looks. And I mean, imagine this workflow yourself. How many is using hot reloading here? Some hands. It's quite a change for us. And I mean, we're, at least I am a bit impatient when I have live reloading and I don't have hot reloading, which is a big step. And then imagine not even having incremental builds or cached builds, just production build with npm installed every time you make a change. That is tedious. Also, we had this other slight little issue that we were all over the landing page. That was not the issue, but down here, I'll zoom in, our peer instances that show the content editors accidentally showed up. Oops. And so, luckily we didn't have any accidents where some copy that was not supposed to go out yet went out. But you know, this could be confusing for visitors, to say the least. So we realized we had some new requirements. First off, we needed kind of section and section templates over page templates. So we wanted to be able to compose complete pages from just a different set of sections that you combine, a bit like Lego. And of course, independence for the content editors. They shouldn't have to wait for 10 minutes every time they make a change. And finally, we wanted some more advanced-ish, at least environment management, so we didn't have to show our pull request instances on Google. And so we created Web Next. And on the left-hand side here, or right-hand side technically for you, you can see somewhat how it looks today, our starting page, landing page. It's built on TypeScript, React, it's server-side rendered Node, it's hosted on Heroku, and it uses something called Storyblock. Storyblock is a CMS we found after evaluating actually a few CMSs, and we made this kind of big battle royale where everyone that knew web had built a small landing page with a CMS that we had found, and we evaluated kind of which CMS was the best one, and Storyblock turned out to be our favorite. Storyblock is a headless CMS, which means it doesn't do templating, it just serves content, which is natural in a way. And it comes with a visual editor, and it has a very nice kind of REST API. And they also just actually released the GraphQL API into beta, or from beta to general availability. So I haven't had a chance to look at it yet, but I mean, Storyblock is awesome, and GraphQL is quite awesome, so it's probably awesome. And they also have an amazing management API, and this was kind of the key selling point for us, because, I mean, if you have worked with CMSs before, if you've worked with, I don't know, even WordPress or something, you're probably familiar with the problem of moving your content schema between different environments. The problem of kind of moving all the fields that are supposed to be there between your dev environment, between your staging and production environments, and so on. And Storyblock comes with this neat little API that lets you kind of handle all of these changes via the API. So what we can do is we can download the whole content schema into a big JSON file, which we almost consider a binary, but we download it from our environment that we work on, and we check it into Git. And once we do that, we can just make a release hook on Heroku that kind of allows us to push this new schema into production or staging or a pull request instance without actually clicking around anything. The visual editor looks something like this. This is our start page, and it's a video banner, so we don't always have a button on our start page. But on the right-hand side, you can see kind of all the different sections that the start page is composed by. And if we move into one of these sections, you will see all the kind of fields that this particular section has. And once you press save, it will, boom, instantly show the content editors what it looks like. As for us developers, this is what we'll see from Storyblock. They will give us a nice JSON response, they'll give us a page title, they'll give us some blocks. In this case, I only show the hero block, which is the component of the block, because you can only fit so much JSON on the slide. And how we go ahead and render this is quite simple. We import just all the different blocks we have. We put them in a map, mapped by the block name in Storyblock. And then we kind of just loop over each block, and we pass all the blocks properties that we get from Storyblock as React props, which means that once we want to render a block, we can use just regular React props, and it gets very easy to test if we want to do that. Storyblock unfortunately uses Snakecase for the API, so it's a bit of a but if that's your biggest issue, then I think we're good. But we're on Google. This is a regular web page. It needs to be server-side rendered. And so what we need to do is we need to run code that is meant to run in the browser on a server. It's magic. Or, because, as we probably know, React comes with this neat little thing called React on Server, which comes with render to string. And that is fairly easy to use. You just kind of pass your React app to it, and it will magically work. Except if you're doing this. What we're doing in this case is we're importing a GIF file as we would normally import an executable script file. That is magic. And that is also impossible because Node will explode and scream at you if you try to do this. So why are we doing this? Well, because Webpack allows us to, and because it won't give you as nice hashes on the content we're importing. But this is super easy to avoid. What we can do with it, as for images, just put them in a public directory and you serve it with your server. As for styling, I would avoid CSS modules, and I would rather use CSS in JS. I'm a big fan anyways. And if you really don't want CSS in JS, you can always use Sass. It's worked for a while. As for SVGs, SVGs are just XML. JSX is XML. Just use JSX. And these are, from my experience, the kind of different assets you may want to import. But, there's always a but. What do you do with the initial states? Because the initial state needs to be available to the server also if we try to render the initial state. So I would ask myself first, before I go ahead and try to render the initial state on the server, do you really need to server-side render it? Or is it enough to just render kind of the loading states? Because if you end up with isomorphic state, or state that is available both on the server and the client, you can say goodbye to local storage and session storage, because they will no longer work, because they're not available to the server, and you have to go back to good old-fashioned cookies. And also, probably you know that React's render function is synchronous. And if you try to do something in JavaScript that remotely tries to do something heavy, such as I/O operations or network operations, they have to be asynchronous. And so you can never, and I guess should never anyways, try to fetch things while you render. And that leaves us with the only kind of way of fetching state is to do it beforehand. So we need to fetch all the loaded states before we render. I know React Apollo, for example, comes with this neat little feature where you can kind of traverse the tree that you make from your app. So if you pass kind of your app that you would render into some function that React Apollo gives you, you can kind of analyze that tree, take out all the GraphQL queries you need, batch run them, and then you can kind of pass the initial state into your function. But it's quite high-tech, and if you don't have GraphQL, it's not really an option. So then you need to know in advance which data you will fetch for every page. In our case, that was quite simple because the only data source we had was Storybook, so we just called Storybook every time, and that's okay. And what we did was we built both the client and the server with Babel. It uses TypeScript, but Babel nowadays supports TypeScript, so that's okay. And we use something called the Webpack Stats plugin, the Stats Writer plugin. And the reason for this is that we still want these nice little hash or chunk hashes that Webpack gives us for our JavaScript files, because otherwise we can't set them to have a long cache time, and so we can never change them, or we cannot cache them. So we need this nice little hash at the end of the file so we can bust the cache. And the problem with this is we don't know what the hash will be unless we have something that tells us, and this is what Webpack Stats plugin can do. It can allow us to write it to a JSON file, and so we can pick it up with our node server. And then it's just a matter of saving it. We're using Koa, so we use Koa static. But if you're using, I don't know, Polka, there's probably something for it. If you're using Express, they come with it built in, and so on. And just to give you a hint of what it looks like, this is very simplified, but this is somewhat what our render functions looks like. So first, we just kind of get the content from Storybook, pass them the cache path, because that's what we base which page to show. And then we wrap it with a nice HTML template. I couldn't fit that on the slide either, but probably all of you know what HTML looks like. And then we just kind of render to string our nice little app. As for the client, that gets even simpler. So our initial state needs to go somewhere from the server, so we don't have to refetch it before we render on the client. But that's very simple to do. And so, what do we do with these environment configurations where we showed up on Google where we shouldn't? We needed one build for multiple environments, because then we can utilize environment variables that, for example, Heroku gives us very neatly. And it's very easy to pick them up in Node. So what we ended up doing was setting 3 environment variables, one that tells us to use auth, and one that applies basic auth middleware. And so if you have basic auth, then obviously people won't access your server unless they should. And this was also one of the reasons, because Netlify, going back to Netlify, they support basic auth, but they only do it on a kind of per branch basis. You can't do it with environment variables. And so if we would have a staging branch and a production branch, we would risk merging the staging branch into a production branch, meaning we would put basic auth on our public website, which would not be optimal. But this solves it very nicely. And so, is it ready for you to kill Gatsby? If you want build different environments, but the same build, maybe. If you want pretty URLs for real-time content that you can't rebuild every time you make a build. And that would be, for example, if you're showing all your users and you want to show user 1, 2, 3, it might be prettier to put the ID in the path rather than in a query parameter. Might not, depending on what you prefer, but for me, this is more pretty. And if you, of course, want server-side rendering of real-time content, so you don't want to rebuild every time you want to server-side render something. Final point, if you're ready to battle Webpack for a few days. This has been, I think, our biggest challenge to maintain and build Webpack. But you know, there's frameworks for it if you prefer. But in our case, we wanted some more control. And this was overall a very fun project to make. And you know, if you're interested, we're Hedvig, we're on GitHub. All our source code is public, so you can check it out if you want. This repository is called WebNext. And surprise, we're hiring data stats. So if you're interested, you know, hit me up after. And with that, I'll open up if there's any questions. One question in the back. Why we moved from Netlify to Heroku? I didn't find any good way kind of hosting a Node application on Netlify, and that's what we wanted. Yeah, Heroku is quite pricey. They are, for sure. Cool. Well, thank you for listening.
Thank you, Johan. If you have more questions for our speakers, they will be around. You just grab them. So this was the last speak for the night, but there will be some more beers for you. They are over there. I'm super glad you all came. I had a good time. Hope you also did. If you didn't, but I'm also a part of a meetup called Fika.js. We're a full-stack JavaScript meetup that hold events every other month or so. If you want to go to a full-stack JavaScript meetup, look us up on meetup. Again, Fika.js. It's good stuff. Before I leave you, I would like to bring up John from Netlight to say a few final words. Where are you, John?
Here I am.
There you are.
I thought I would do this the very last thing.
Oh, the very, very last thing.
Yeah.
Well, we'll have to do it now.
Yes. Great. Yeah, so I was actually away and I got some stickers when you were talking, so maybe I will repeat something. But thank you so much for joining us here tonight, and we want to just mingle a bit here, and hopefully we will do this one more time. That's it. Thank you. And don't forget the alarm and the handle there.
Ja, bra. Verkligen alltså. Cool success. High five. High five. Boom.
Let's dance in front of Let's dance in front of the camera.
Dance. This will be a meme.
Is this a new tradition?
Yes. I think it's cool. It should be happening everywhere. We're having a party.
Yeah. This is how you make a fool out of yourself on internet.
Exactly.
Nice.